and welcome to the Cup of Comp Sci. So today we're going to be walking through just the basics of GraphQL, and we have the documentation on the right hand side. So it's all right there. I'm going to just be walking through the documentation and basically what GraphQL is. So we'll see some of the code that is used in GraphQL, as well as a general overview, but we won't be coding in this video. Hopefully there'll be a video coming out on that soon in another one of the explorations that we do. But let's start off with what GraphQL is. So GraphQL can be compared to the REST API. So REST is just a way for a client to get information or to send information to and from a server. So this client could be a mobile app, a web app, etc., and the server is usually like the back end, more or less. And it has access to databases, etc. And with the REST API, if you want information about a specific user, you can use a GET request followed by the endpoint you're trying to hit. So if I have www.mywebsite.com/user1, this would get me information about my user, but it'll give me every single bit of information about the user. So let's say the response in this case will have a name, and the name, let's say the name of the user is Emma, her age is 17, and her email is something, and then her favorite color is something else, etc. So it'll give me every single piece of information about Emma. Now, let's say we do a similar query using GraphQL. So that would look like this. We want to hit the user endpoint. The user endpoint, and we want, let's say, just the name and the email instead of every single piece of information. So we specify name and email, and that's it. The response will have only the name and email of the user. So that's really nice. And with GraphQL, the other benefit is that if you want information about a product, in REST API, you would need to make another request in addition to the user request. So you have another GET request and www.myweb.com/product/1, and that would give you another response with information about the product. So you have to make two separate requests if you use the REST API. But if you were to use GraphQL, you can get all of this information with the fields of your choosing, so any field that you want, and it's just in one query. So I can amend my GraphQL query. So I'm going to use a darker color purple for the amendment. So I specified user, name, and email, which is the first part of my query, because I still want user, name, and email. And I also want information about the product. So I'll have product, and let's say I want only the product name. So I specify product name and close parentheses for my query. And that's it. With this one query, I can get all of the data I need. So I'll get name and email of the user and the name of the product. So one query, one response with GraphQL. So from the user's perspective, there's a single endpoint, which is better than sending 2 requests, which is what happens if you were to use the REST API. So that's the basics of GraphQL. Now we're going to go into the difference between a query and a mutation. So GraphQL has these things called queries and mutations. This is equivalent to the REST version. So a query is equivalent to the REST version of a GET. And all this is saying is that you want to retrieve information from the backend, but you do not want to modify it. So that's what a query operation type is. A mutation operation type means you want to create something new or update the data. So it's similar to like a patch, delete, etc., as is in the REST API. So basically, mutation equals changing data. But a query is just not changing data, but just getting data without changing. This triangle, by the way, is a delta, so it means change. All right. So we've talked about the difference between a query and a mutation. There's also something called a subscription, but we'll not go into that right now because I think it's not as common, but it's just another operation type. So queries are interesting because queries happen in parallel. So if I have a request like this with the user and product, this would go to the user section at the same time that this would go to the product section. Or basically, it'll happen more or less at the same time. It's not concurrent. Whereas if this was a mutation query, it would happen in series and not in parallel. So if I have a mutation query, the first part will get executed before the second, so that you're guaranteed that there are no race conditions. Okay. Another quick thing to note, just syntactically, is that you can have a comment in a query. So in this case, I can have a hashtag comment, and anything I write here is just a comment. It won't be executed in any way. It's like a normal code comment. So going to the documentation, we've gone through what GraphQL fields are. So this is just a query for hero, and specifically, we're asking for the name field in the hero. So that's what we receive as our response. So we have data, hero, and we get the name of the hero, which is R2D2. We've spoken about the fact that queries can have comments. We'll now talk a bit about arguments. So we have our query, and then we want to get information about a human where the ID of the human is 1001. And specifically, we want the name and height fields of the human. So this over here is an argument. So this is the way we've specified the human field in our resolver, which is why we've said that this argument is ID, and this is the value we're passing in. If I had called this apples in our resolver, we could have written apples over here. Notice that you can also change this value. So instead of 1001, where I get dot Vader as the name and this is the height, I can maybe get 1000 and I should get Luke Skywalker instead. So the ID will change the name and height because a different human is retrieved. All right, so that's an argument. We can then move on to the fact that you can have multiple arguments here depending on how you've defined it in the resolver. So you could have ID as 1000, and let's say if your resolver had another field, like for example, M is 3, you could have it written out like this. This is fine. In this case, it's erroring because I don't actually have a field called M in the resolver, but you can have something like this to pass in multiple arguments. Okay, we'll talk a bit more about resolvers later, but let's also dive into the fact that you can have arguments on fields. So you can pass in arguments into scalar fields so that you have data transformations on the server itself instead of doing these transformations on the client. So in this case, we have height, and this height takes in an argument for unit, and we're calling that argument foot. So height, so the unit is actually on the back end defined as an enum, and the values you can take are either meter or foot. So we pass in foot over here, and this will give us the height in feet. And height is just an integer. Sorry, not an integer, a float. Okay. All right, so this is another benefit of GraphQL as compared to REST. So over here, you can actually specify the argument. You can actually specify the arguments on a scalar field. So you might be wondering about the types that GraphQL has. Let's actually go through that really quick. All right, so GraphQL has a type system, and the GraphQL queries always start off with a special root object. So as written over here. Okay, so you'll have your query, and this is actually the root. So think of it as something over here, and inside that query, you might have hero. And then we have name and appears in. So the special root object is at this level. What happens then is it'll go to this and then look at whatever's here. And then if it's a query, and if you have another query, let's say for another kind of hero over here, it'll go to this simultaneously. Every GraphQL service defines a set of types which completely describe the set of possible data you can query on the service. And when the query comes in, the query is just validated against that schema. So if the type doesn't match, you'll get an error. There are different kinds of, there are different types that are defined. And I believe the best way to go through this is just to start off with these scalar types. So the different kinds of scalar types are, let me just choose a color. Okay, so you have an integer, so int. So these are the scalar types on the right. And you have an int, which is basically just a number without a decimal point. You then have a float, which is a number with a decimal point. You have a string, which is a set of characters, so a sequence of characters. You have a Boolean, which is either true or false, and you have an ID. So the ID scalar type is basically like a string, but it's not meant to be human readable, and it's used to uniquely identify something. So those are the basic scalar types. You can also create your own scalar type, like this, so scalar date. And when you create your own scalar type, there's a way to specify how you want the type to be serialized and deserialized. And serialization and deserialization, if you don't know what the term means, it's just basically a way to convert something so that it can be sent across and then unconvert it back into some other type. So that's deserializing and serializing, respectively. Okay, there are also enum types, and enum types are like in any other language. In this case, we have an example. So enum episode. In this case, this means that the episode enum type can only take the values of New Hope, Empire, or Jedi, so it can't be any other value. There are also lists and the non-null type. So for a list, you just have these square parentheses, and a non-null type just says that the field cannot be null. So in this type, so we have a type character, we have name string, and this string cannot be null because it has the exclamation mark. So that's the non-null type. There's also the appears in field, and this is a list of episodes that may or may not be null, but the list itself will not be null. So if you want to have a list of non-null episodes, instead of writing something like this, you would write appears in, and then a list of episodes, so episode, followed by an exclamation mark indicating that it's non-null, and then another exclamation mark indicating that the whole list itself can never be null. So if you didn't have the last exclamation mark, you could have appears in have a value of null. That would be valid. Okay. So we've specified that. Notice in this example, we have an ID value of null, and this is an error because ID can't be, it's a non-nullable type, so it can't be null. So if we remove that, this should be fine, but the way we've defined it in the backend is not this way. As the error says, we need the exclamation mark because that's how we define it in the resolver. So you need to specify a non-null ID. So something like that, for example. Okay. Note that if you send a field with the wrong type, you will get an error message as the response. And we'll see more of that a little later. So you can also have normal types. So we've seen like this character type, it's just a normal type. That's technically still a type in GraphQL. And you can also have interfaces. So in this case, we're going to be defining character as an interface. So this is similar to the concept of interfaces in other programming languages. With an interface, what's going to happen is that the interface needs to be implemented by another type. And all the fields specified in the interface must be included in that type. So since we have the character interface here with the ID, name, friends, and appears in fields, if we have another type, for example, the human type, which implements character, that human type needs to include at least all of these fields. The human type can add its own fields if it wants to, and in this case it has. It's added starships and total credits, but that's not necessary. It needs to include at least this, so minimum. All right, so we have the human type and we have the human type and the droid type, which implements the character interface. So that's another type we could have. And this is just an example of like an error message you might get. So in this case, we have an issue. So let's figure out what the issue is. We have a query which takes in an episode variable. We've not seen variables yet, although we've seen arguments, I think. So just think about this as, so a variable is anything that has like a $sign, and the type in this case is a non-null episode. So we have this variable and it can be used anywhere in this fragment or in the query itself. So we have our episode, so hero, where the episode equals to whatever episode this is, in this case Jedi. And Jedi is, so what's the type of Jedi? So it doesn't have a primary function. It's not a droid, which is why we can't do this. Or is it a droid? Let's find out. I believe it's not. So if I were to remove this for, yeah, okay, so Jedi is a droid. But even then, this is an issue because hero could be a human or a droid. And this is going to error because it doesn't, so the hero is actually a character, and character does not have the primary function field, even though droid does, and even though Jedi is a droid. So the way to fix this is by using fragments, which we'll talk about later, but just know that right now, as is, this will cause an error, as we saw earlier. So this is the way we actually solve this issue. This is a fragment, and we'll look more into it a little later. The last type that or the penultimate type, so there's one more after this. The penultimate type that we're talking about today is union types. And a union type is just a combination of other types. So in this case, we have a union type called search result. And this type is either a human, a droid, or a starship. Note that you can't have an interface as one of these three things. It has to be a concrete type that has implemented an interface, or it's a type itself. So no interfaces, only concrete types if you have a union. All right. The last thing that we should talk about is an input type. So this is the last type, at least in the documentation. And an input type is used during mutations. So we've spoken a bit about mutations in queries, and the way you tell what a query is and what a mutation is by just specifying the operation type. So you can have mutation, the name of the mutation, and the actual body of the mutation, or this could be query instead of mutation. So in this case, we have a mutation, and the mutation takes in two arguments. So we have an episode, which is non-nullable, as well as a review, which is a review input. And this review input is an input. It's not a type. We need to have an input because this thing is going to be used as a way to create a review. So it's being used as an input into our server. So we need an input type. I keep saying input type, but it should be, we need an input. The type is called input, but I hope you get what I'm saying. All right, so we have an input, and in this case, we've defined our input to have a stars and commentary field. So looking at our variables, the first variable was episode, which is non-nullable, and this is an enum, so this is fine. It's fine to have enums and scalar types as arguments in mutations, but you cannot have a type, like an actual object type. So that's why this needs to be an input, since it's an object. And we specify stars and commentary, because that's how we define the input. And then we have our query. So we have create review, which takes in this episode and the review. And the response will have stars and commentary. So this doesn't need to be stars and commentary. We could call this type name, and that's fine. But what's being returned is the review, basically. It creates a review, and the review created has a type name, which is what it's returning. You can call this, you can basically request any field here. If I want only commentary, it's fine. I will get only commentary. And that's of the newly created review. Okay, so those are the types. So just to recap, we had the basic scalar types. So if I write that out, hang on. My pen and mouse have stopped working, I think. Oh, it's because I have an eraser. Never mind. Okay, so if I were to write out all the types that we have, so we have scalars, and this is, yes, types, scalars such as string, int, float. We also have Boolean and ID. And you can also define your own types if you want to. So your own scalar types. We also have the list type. We also have the non-nullable type. We have the union type. We also have like the normal types. Like you create your own object. We have interfaces. And we have input, which is used in mutations. So that's the GraphQL types we've gone through. Now, going back, we have aliases as our next topic. So what does the word alias mean? It's just another name for something. So let me quickly refresh this. Okay. We have aliases, which are another name for something. And let's just look at this query. I'm going to change the query a bit. So let's say we want a hero where the episode is Empire, and we want another hero where the episode is Jedi. So we want the names of those heroes. This is giving me an error because on the same level, a query can't have fields with the same key. So the response over here is going to be called hero, and if this were to go through, this would also be called hero, and that's not good in a dictionary. So we need to rename these. So we have this hero where the episode is Empire, and we have this hero where the episode is Jedi. So to create an alias, I just have the name of the alias followed by a colon, and that's it. In the response, we're going to have Empire hero, and over here we have Jedi hero instead of hero, and that's fine. So this is just another name. I can call it whatever I want to. Yeah, I can call it search, which is a name of another query. And that's fine. I can call this Starship, and that's also fine because it's an alias. Okay, those are aliases, but let's talk a bit about fragments. A fragment is used when you want to reduce the amount of code you're using in the sense that you want to reuse code. So let's say we want to create a query for a hero. So I'm going to create a query, and I have a hero where the episode is Empire, and I want to retrieve the values for the hero name, the hero appears in field, the hero friends field, and specifically the name of the friends, etc. And then I want the same information for another hero, but the episode this time is going to be Jedi. And so because of this, I have to like literally type out all of these again. So it'll be name, appears in, etc. So to avoid this code repetition, we create a fragment. So that's what's done over here. We take the common part, which is name, appears in all of those fields, and we put it inside this fragment. So that's our fragment body. The fragment then has a name. We can name this whatever we want to. I can call it D, and it's fine. Well, it's supposed to be fine. Hang on. Yeah, so I can call it D, and this is fine. And this fragment is on character because this over here, or this over here, is a character. Hero is a character. So we create the fragment on the character because the fields of character that we want are these fields. So that's how it actually does its validation. It knows that these fields have to be in character. Okay, this makes sense, hopefully, to everyone. Now this section is, so this whole section over here is the actual query, and it has an alias, because remember we can't have two things called hero. That causes issues. So we call the first one left comparison. It's an alias, so you can call it anything you want to. I can call this A, it's fine. And this is the right comparison. I can call it B, it's fine. And inside the queries, you have dot 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 D. So D is the name of the fragment. So this is just as good as copy pasting this, putting it in here, copy pasting this, and putting it in here instead. So the response this gives us is A, then the name, the appears in value for like that hero which appeared in the Empire episode, followed by the friends' names, as well as the value for B. So we have B over here, and this has name, friends, appears in, etc. So it's basically just condensing that query using a fragment. You can have variables inside fragments, and the way you do that is you just specify it this way. So remember, we create variables using the $sign. And in this case, we've called our variable first. The type of the variable is int, and the default value is 3. You can also reference this variable inside the fragment itself. So in this case, for friends connection, it's going to use the value of this variable, which is 3. Let's talk a bit about inline fragments. So having it in line with the query, that's an inline fragment. And we've also seen an example of this actually over here. So this is an inline fragment. We skimmed over it when we were going through types, but let's discuss it now. So remember we had the union type, which was a combination of different types. Well, if you have a search query, and the search query works like this. So the way we've implemented it is that it takes in a field called text, and the value of text is an. So if the name of the character contains the letters an, like this, like this, Han Solo, Leia, Organa, or TIE Advanced X1, then that object will be selected and the corresponding fields will be returned. So if the object is selected, the type name will be returned. And if the object is a human, so this is an inline fragment, because if that character is human, then we return name and height. If it's droid, we return name and primary function. And if it's starship, we return name and length. So that's what you'll see over here. And we need this because human and droid and starship might have different fields, as they do in this case. Like humans have height, droids don't have height, but they have a primary function. So inline fragments are really important, especially when we use unions. You can also do something like this instead. So this and the thing above produce the exact same result. But what this has is you have a section for character. So if it's a character, the name field will be returned. So humans and droids are characters. So instead of having name written out twice, you can just have it on character, then name will be returned. And then if it's a human, height will be returned as well. So you'll have name and height returned if it's a human, and name and primary function returned if it's a droid. Because droid and human implement the character interface. Okay, so we've spoken about fragments. The next part is about operation names. Okay, so you might have noticed that the way we've seen queries in GraphQL, at least in this video, is twofold. So the first way was we had query followed by a name and then the body of the query. You've also seen me write out queries without the query and the name. So something like this is still valid. So you might be wondering, if both of these are still valid, what's the point of doing this? Well, both of those are still valid queries, but doing this lets you specify the name of the query. And that's very helpful when you want to log the actual query that was sent to your service, maybe for debugging purposes and many other purposes. So just logging the name is very helpful. And if you don't specify query and then the name of the query, you can't pass in arguments on the very top. You can't have something like this. So if I have something like a variable for ID or variable for M of type int with default value 2, this is not going to work this way. But if you want to do this, you need to have the operation type, which is query, and the operation name, You can call this anything. In this case, they've called it hero name and friends. I can call it M. It's fine. And the values passed in. So if I had an ID field of type ID, for example, with a value this, it's fine. It's erroring right now because it's an unused variable, but this would be fine in other cases if it was used. But it's not fine if you don't have this section. Okay, so that's the operation type. You can specify query, subscription, or mutation. Again, we've not talked about subscription in this video, but maybe in a future video we might talk about it. Okay, so we've spoken about operation name. We know variables, where the variable you just specify the $sign. And the reason you have variables is because it's easier to have a separate section for the variables rather than having your query and then in a program, if you're writing this out in code and if it's being constructed by a program itself, you would have to like piece together pieces of the string if you didn't have a variable. So it'd be like the first part of the query and then piecing together the value of the variable, and then second part of the query, value of the variable, third part of the query, value of another variable maybe, etc. So it's a lot of string concatenation, and to avoid that, you just have the separate variable part passed in this way, so that the value of episode will be Jedi. Okay, we've spoken about variables. We know that you can specify a default value for a variable. So in this case, you can call the query without passing any variables, but if you pass in a variable, this value will be overridden. So it's like a normal default variable in different languages that you have today. Okay, directives. So directives in any language are anything that have an @ symbol that way. In GraphQL queries, you can have directives, and the two most common directives are for include and skip. Okay, so what is include and skip? So what do these directives do? Let's look at this example. We have a query for hero, and this takes in two arguments, one for episode, one for with friends. So these are variables. And we pass in values for those variables here. And the actual query says we want a hero which has this episode, and specifically we want the name and friends of the hero, but we only include the friends field if this is true. So if with friends is true, then we include it, else we don't. So if I change this to true, you'll see that the friends result shows up here. If I change this to skip, it's going to skip including the friends field if this condition is true. If I change it to false, the friends field will show up. So that's the directives in GraphQL. We've already spoken about mutations. If you're creating a mutation and if you need to pass in an argument or a variable that isn't a scalar type, that is, it's an object, you need to use an input type. Okay. So we've spoken about how queries and mutations, so the first one is in parallel, the other one is parallel. Did I misspell that? It's okay. Yeah, parallel. So the first one is in parallel, the mutations are in series. We've spoken about inline fragments. Let's talk a bit about meta fields, and then we can move on to another topic, specifically validation and about resolvers themselves, which shouldn't take too long. But meta fields. What are these? So meta fields are used in introspection, and it's a field that is information about the information you create. You don't need to do anything extra. The meta field is just provided for you, so you don't need to do anything extra on the back end. But if you query for like type name, which is a meta field, you will get a value. And a meta field is anything with the underscore underscore. So that's generally how they are written out. So 2 underscores in front. And this is a type name, which is a meta field. For a human type, it'll have type name as human. For a droid type, it'll be type name droid. For a starship type, it'll be type name starship. So there are a number of meta fields that you can use, and it's used in introspection a lot. So introspection is when you want to look into the server through queries, essentially, in this case. Of course, if there's a schema defined somewhere else, that's fine as well. But if you want to get the schema using queries, you can do it this way. So you have the schema meta field, and if you want to know what types are available, you then have types. So you have to call it types, and then if you want the name of the type, you just put name. So this response just gives you all the types that are implemented in the backend service. So we have a lot of types. So there's like query, character, human, episode, droid. So these are types that we've defined in our type system. We have string and boolean. So these are built-in scalars that the type system provides. And you also have other meta fields, which are also provided for you. So these are part of the introspection system because they have these underscore underscore characters before the word. Okay. Now we want to find out what queries are available. So the root level thing is called the query in this case. At least that's how we've named it. So you can do something like this, query type, name, and that will give you the name of the query type. So the root level is query. Now let's say you want the type of a specific type and you want the name of that type. So you can do type droid or type human, so the name is droid or human. And if you want only the name, then you have name. If you want the type, you'll need to use kind. So in this case, kind is an object. So droid is an object, so that's fine. And kind returns a type kind enum, one of whose values is object. If we asked about character, we'll see that this is an interface. So we can also do introspection to know what fields are available in the droid object. So we have name, which is droid, and then we have fields, because we want information about droid fields, and we want the name of the fields, and the type of the fields, and about the type, we want the name and kind. So let's look at the response. Droid has a lot of fields. So we have ID, we have name, friends connection, etc. The type of the field will have a name. In this case, it's null, and we'll talk about this. The kind is non-null. We'll talk about that as well. And you'll see that repeated in a lot of things. For friends, you have the kind as a list, but the name is null. Okay, so let's talk a bit about the fact that ID had type as null, the reason this happens is because it has no name for the type, because the ID is of type ID, and ID is just a wrapper type of kind non-null, because ID can't be null. If we queried for of type, that would give us the ID type itself. So let's look at that in example, because it's a little hard to follow along. But if we have type and instead we query for of type, that will have the ID as the name and kind as scalar. Okay. But yeah, just something to note that this is just a form of introspection. The best thing to do is to maybe just come back to the documentation when you do need to do introspection, because it's hard to remember, I guess, this specifically, because I don't think it'll be used as often as other things. But yeah, that's true for anything in computer science, so yeah. Okay. You can also have like a description field, and this is particularly useful if you want to like have it ready for the user for like tooling, and so they know what it is because you have the documentation right there in the description field. Okay, so that's introspection. Let's move on to validation. So with validation, if a query is invalid, you will get something like this. You'll always get errors, and it'll be a list of errors, and there will be a message which will tell you what the issue is and the location of the issue. So line 11, which is around here, I think that works out to 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. No, it's 11. Okay. Yeah, so line 11 is where the issue happens, and it's column 5, because like 4 spaces here, and then 5. So this is where the issue starts. So it tells you the exact location of the issue in the query, which is nice. Okay. We can have multiple errors, because errors is a list, and the message is usually very descriptive. So I won't walk through all the errors that you could get. I guess that'll just come with practice. If you make a query error, you'll see the error message. And Stack Overflow might help, all the documentation might help. But yeah. So validation is done. And if the query is invalid, this is the kind of response you will get. Let's move on to execution. This will be the last part of our session today. And with execution, we already know how we write queries, but let's look at the actual backend. So we can create types like this. So you've seen this before. We can create enums and types and other different things on the backend. And when we query it, we'll get values for it. But to do that, we need to create a resolver so that we know that when we get human over here, we need to resolve that to a human object so that we can get these types. So we have something called the root resolver, and root is basically top level. So the top level resolver is a query. So at the top level of every GraphQL server is a type that represents all of the possible entry points into the GraphQL API. It's often called the root type or query type. So in this example, we have a query type, and the query has human. It can also have other things. So you can have, after this section, you could have maybe a resolver for hero, etc. So human has these 4 fields, and so this resolver what it does is it'll use this field, so all these fields, or some of the fields, and it'll return a human, because that's what this resolver does. This is called human, it'll return a human. So if I write a query, and if I call this human query, this will be human. It'll return a human object. If I call this human big, in my query itself, I would need to write human big in order to use that resolver. Okay, so let's look at what the arguments for this resolver actually are. So note that you can actually write resolvers in different languages, and GraphQL is supported for multiple languages. So if you go here, this is the list of languages it supports. It's like huge. There's like C, C++, Go, Ruby, Scala, D. I've never used D. I've heard of it, but yeah, it's like a lot of the support for a lot of languages. Okay. So the resolver function receives 4 arguments. The first argument is called object. So this is just the previous object. And this doesn't really make complete sense if you're looking at a root field, so it's very rarely used. It's just like the previous level thing. So in this case, I feel like object might be the entire query, but that doesn't make sense to use it here, because it's just a thing that's on the previous level, basically. Args is just the arguments passed in. So in a query like this one, you have these arguments. So ID is 1002, so that would be a field in args. So to access that, you do args.id to access the ID field. Then we have context, and context is a value which is provided to every resolver. It just has contextual information, so it could have maybe the information about the user or access to a database, etc. So in this case, we have context, and then we also have info. Info has field-specific information relating to the current query as well as schema details. We won't dive too much into it for now, but there are more details here if needed. Okay, let's look at the body. So this is a function, right? This is just basically a JavaScript function. And the return type is going to be human, so whatever human is. And the way we do this is we look at the context, we get a database. In our example, you don't have to do this in every example. Yeah, so in this case, we look at the context database, and we get the human by ID from the database. That's what this section does. Once that is done, we're using a promise here, which is why we use the .then keyword. And this is just a JavaScript thing to have async requests. But once we get the human, we then create a new human object using the user data returned by this. So this will give us user data. We then take that user data and construct a new human object, and that's going to be returned by the human resolver. Okay, so these resolvers can be asynchronous, like the one we just saw. Instead of like having .then, you could just return new human user data after you do this. So basically user data equals this, and then new human user data, just return that. But that's not asynchronous. So this might be better, depending on what you want to do. But the point of the matter is that this asynchronous request is a promise. So what it's going to do is wait for this. Sorry, what it's going to do is not wait for this, but once this is completed, then this will definitely be done, and that will be returned to the human resolver. So that's the return type of the human resolver. And you can also use futures, tasks, or deferred. So that there are different asynchronous things that you can use. But this is just one example. You might be wondering, can we have, well, do we need to write out resolvers for everything? So if you have a human and you want to resolve the name of a human, do you have to write object.name? Because object over here is just going to be the thing on the previous level, which will be human in this case. And human.name is what's going to be returned, which is name. So a lot of the GraphQL APIs out there will actually let you omit writing out this resolver manually, because all it's doing is looking at the object and getting this field. So this is actually done for you in a lot of the GraphQL libraries. So depending on the library you use, you might need to include it, but oftentimes you don't need to write out these trivial resolvers when you just want a field in the object which can be accessed by using the dot notation. And basically, the rule of thumb here is if you do object and then this dot this field, that's a trivial resolver if that's the return type. Oh, sorry, if that's the return value, right? Okay. Scalar Coercion. Okay, this is interesting. So if you look into the resolver for appears in, so human.appears in is what's going to be returned here, and appears in is a list of enum types. But if you print this over here, it might show you a list of integers. So if you see this, do not be worried. What's actually happening is that the GraphQL type system knows that these integers are enums. And so it'll coerce these scalars into the enum type when needed. Okay. We also have a resolver for lists. So if you have starships, so human starships, this can potentially return a list. So what it's doing right now is it's looking at the object, which is human. It gets dot starship IDs, which is a list. And so this is a list of IDs. At this stage, it's a list of IDs. Then we're using the JavaScript map function to take an ID, look it up in the database, and once the value from the database is retrieved, then it will do this. So it'll take the data and it'll create a new starship. And this is done for each starship ID value. So you're going to have a list of starships at the end of this, which is what the resolver will return. Yes, so this is just the resolver in action. You have starships, and it's a list of, well, if you include every single field in the starships, all the fields will be included here, but this is just the name of the starships that we resolved. Okay, so with that, I'm going to wrap up our GraphQL, more of a theoretical exploration today. Hopefully in the future, we try out some coding with GraphQL, so maybe in a future session that we have here on Cup of Comp Sci. But for today, that's it. Thanks for watching. And almost Happy New Year. So yes, right, see ya.